What's going on, guys, and welcome back to the channel. As you probably would have guessed, I haven't been uploading since the past year, I believe, and that's because of schoolwork and everything. I probably assume you all students understand. And now because of the new coronavirus issue, I had some time and I thought, why not continue this channel? And to start things off for the new season of the channel, I've decided to perform a math tutorial video. And you probably would have guessed from the title, we're going to be talking about scientific notations. While you're watching the video, remember I have a context right at the start of the presentation coming up, and I have not covered all the aspects. So please keep on watching and enjoy the video. So without any further ado, let's begin. First, I'm going to start by talking about the plan. So today we're going to talk about the purpose of scientific notation's existence, the basics, like the constant rules that can be applied in any situation with such problems as we're going to discuss today, big numbers to scientific notations, scientific notations to big numbers, so vice versa, small numbers to scientific notations, and scientific notations to small numbers. The next one might come as a surprise to you. It's metric conversions using scientific notations. And I'm going to explain later on in the video why these actually work. So yeah, that's just an image. So the purpose of scientific notation. So scientific notation simplifies the method of writing big and small numbers. It reduces the amount of space required. For example, you don't have to put millions of zeros behind something. It eases conversions of such extreme numbers. Yes, I'll talk about the conversions later, as mentioned previously in the video already. And eases the effort required to perform bigger calculations on smaller or bigger numbers. So and helps avoid careless mistakes with numbers, including a lot of decimals or a lot of zeros. Why did I switch to that accent for a second? Yeah, forgive me. So if you're writing a number, let's say 50 zeros, yeah, that's a thing. So you would have to write 0 50 times, and you might actually mess up or make a silly mistake, causing a big mistake. Yeah. So this is another note. I have recently researched a lot about this, but there are three different types of learners. There are audio learners, visual learners, and tactile learners. I'm personally a tactile learner, so I would take notes if I were you. If you're an audio learner, focus on my oral explanations, and visual learners, focus on the written explanations. Most of the things that I talked about are listed down. So let's start with the basics. So constant rules and the equation. So the equation of scientific notations is x is equal to a times 10 to the power n. X in this case stands for any rational number. A is a number between -9 and +9. You might not have learned this in class yet, but yes, you can use scientific notations for negative numbers, which is pretty simple. I'll tell you about that later, yeah. N is the power of 10, which manages the decimal places. So what we're doing in scientific notations is basically going through the decimal points. So you're writing a big number as a decimal or a small number as a bigger decimal. So you want to use the power to move the decimal places to eventually reach that particular number. So the basic hacks, I would like to call them. 0 times 0 as in x is equal to 0 times 10 to the power any number. Single digit number is itself times 10 to the power 0. By that I mean a number like 1 is 1 times 10 to the power 0. A number like, let's say, 80 is 80 times 10 to the power 0, because anything times the power 0 is 1. If x is negative, then a is negative. nothing else changes. Yeah, so we're talking about it now. So let's say you're taking 700. 700 in scientific notations would be 7 times 10 to the power 2. On the other hand, if we're talking about negative 700 would be negative 7 times 10 to the power 2. So nothing else but the a in the equation changes. If a less than or equal to x, then n is positive. If a is greater than or equal to x, then n is negative. We'll see that later. So let's officially begin learning scientific notations. Big numbers to scientific notations. So we're going to be taking a look at these two examples. This is 100 billion. So this would be the scientific notation form of 100 billion. So let's see how it came up this way. This is because, see the 1, it's carried over because 1 is the only number with a place value of higher than zeros in this particular number. It has to be the value of a. And the point 0, you normally don't put that. It's just there to explain how we're going to move the decimals. Times 10 to the power 11 is because there's only one number and the decimal point is placed right after. So if you were normally to move decimal point, you would count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, which is 11. But an easier way to do that is just by counting the zeros. If you're someone like me and you're tactile and you don't like all those lines, you just want to use the numbers. Yes, and just count the zeros. You can recheck it by pausing the video. It's 11 zeros. And you might have seen my old video. I always like to check my answer. So we'll just put this in the calculator. There's a button in every calculator saying times 10 to the power x. So all you have to do is press that. And after pressing the number, just press the power. And the answer is 100 billion. So it's a tick. By the way, all these answers are checked on a real calculator. So don't worry. Second example, 536 million. 536 million. So 536 million is equal to 5.36 times 10 to the power 8. So in this case, you can't really count zeros. You have to count logically. Basically logically, yeah. Because 5 is the leftmost value and it has the highest place value, not face value. The last one has the highest face value. If I said that wrong, I think I did. Because 5 has the highest place value, it is a number that's going to be placed before the decimal. And another PPT error, it's not 0.64, it's 0.36. So decimal point is after 0.36 because they're also values with a higher face value than 0. So because there are 3 digits in the number with a face value of higher than 0, the decimal point is placed right after the one with the highest place value, as explained before. The remaining digits are still included in A due to all their face values being higher than 0. Confirmed. To calculate the power, just count the number of digits after the first digit. And it's also a little hack. So just ignore 5, start counting from 3. 1, 2, 3, 4, 5, 6, 7, 8. That's 8. And notice the power is also 8. Remember, don't do that if you're just starting to learn this. After you've understood the concept, I think you should be able to do this, but you shouldn't do it without, not understanding the concept. So here's my calculator and boom, it's accurate. Yeah, I did a lot of research on this, by the way. And scientific notations to big numbers. So now we're going to do vice versa. So these are the two examples we're going to be taking a look at. This is 1 times 10 to the power 13. So 1 times 10 to the power 13 is 10 with 12 zeros behind it. So this is the way 1 times 10 to the power 13 is written, because you look, 1 is transferred. So what we did before, but vice versa. If it's a single digit, just put it there. And yes, it's highest place value and face value. Yeah. So the basically vice versa again. So the digits that include an A that are behind the decimal point are the ones with the highest place value. So it's only logical to put it in the leftmost side of the right side of the equation. The power 13, however, represents the number of zeros, as we talked before, and now vice versa. So if there's only one digit, then you can just put a 1 and count 13 zeros. Same warning, understand the concept before you do this. Calculator time, and it is 1 with a 13 zero, and it's correct. So also, maybe if you're finding this a bit too fast, just slow it down or leave it in the comments if you don't understand anything. So 5.746 times 10 to the power 6. Remember, always count the numbers after the decimal places with their single digit value. So you're not going to say 5.746. It's always going to be 5.746. So same thing, but this time it's a bit different because it's not a one digit. So look carefully. Feel free to pause the video if I'm going too fast. Slow it down. Because 5 is the leftmost value, it has the highest place value, and it shall be placed after the decimal point, so it's only logical to put it on the leftmost side. So what I would recommend you guys to do is just, kind of copy paste this into the equation on the right side, and the zeros and the decimal moving is what takes place next. So this power 6, you will notice, is a bit complicated than what we have done previously. So if you want to read that. I'm just going to give you a small summary. So look, because there are 3 digits after 5, the one with the highest place value, and we're moving the decimal, we would count like 1, 2, 3. So now we have 5,746. Now we're gonna place the rest of the zeros as discussed before. So 1, 2, 3 again. That's 6 to the power 6. That would give us the answer 5,746,000. Now let's check it. Yeah, my tone went a bit wrong. So 5,746,000 is the right answer for this. So it's a thumbs up. It's a big thumbs up. Next we have small numbers, 2 scientific notations, and that you can see is going to get a little bit complicated, but there is a very valid hack that you can use to perform these calculations way faster. So these are the 2 examples. Sorry, I skipped through that fast. So this is 1/10 billionths. So 1/10 billionths. Yeah, to be specific. I do weird things sometimes. So that's how you would write 1/10 billionths. You would say 1 times 10 to the power -10. Now, if you recall back to our basic rules, if x being 1/10 billionths is smaller than a, which is 1, the power is going to be negative. And let's see how this is solved. That's a big curve. Oh, so because 1 is the rightmost value it has the lowest place value. It has the lowest place value. Notice the difference, like in big to scientific notations and scientific notations to big number conversions. We normally look for the value with the highest place value. And now we're looking and finding the lowest place value. And the one with the lowest place value should be placed behind the decimal. Well, not really, but if there's one digit, that's what should be done. Or in an easy way, just kind of copy paste the numbers with higher face values than zeros to the right side. And then now let's talk about how we got the -10. So there's one thing about small numbers to scientific notations and vice versa conversions. It's that because the decimal point is placed in such a manner that you'll always be able to calculate the power just by counting the number of zeros. For a second, just forget the decimal point, count the numbers of zeros. I'm going to give you guys some time. That should be enough. And that is no doubt 10 zeros. So this mainly works because, look, we move the decimal through all the zeros and place it right after that one digit we put into A, right? And skipping that one digit can be cancelled out by the zero located behind the decimal point, making it so that we can just count the zeros and solve for the power. I hope that helps. It helped me a lot. So that's the number. Put it into the calculator. Use the equal to button, and we get 110 billionths, and it's 100% correct. So I hope you guys enjoyed the video. Yeah. 473 10 millionths. Yeah, go and check out how decimal places are pronounced in English or said in English. It was hard for me to learn too. So you would write this thing as such. This I have majorly discussed almost everything before. So because it's similar, so I'll just do everything and then I'll quickly explain again. So as I said, in one digit numbers, you just look for that one value which has a higher face value than zeros and you put it in A. In this situation, however, because we want A to be between -9 and +9, it has to be like a ones digit. It has to be a ones. So that's actually a built-in hack in small numbers to scientific notations, is that you only have to move the zero until you reach the value closest to the decimal point, which has a higher face value than zero, if all that makes sense. And you and after you have achieved that, you can basically copy paste the remaining numbers into the side of A, which means an easier way to understand this and fit it in your brain. It's you're kind of just looking for the values with a higher face value than zero and putting them as it is on A. But you have to perform certain decimal movements, which I'm explaining to you. And the -5, as I've explained, this always works in small numbers to scientific notations and scientific notations to small numbers. You can just count the zeros. So look, this value, yeah, value is the right way to say it. 1, 2, 3, 4, 5. That's 5 zeros. This only works in small numbers and to scientific notations and vice versa because you're just moving the decimal point and not to the end of the value so that you have to count all of it, but to a point where you can get a ones value, like ones, tens, hundreds, that ones value. and we're trying to make the number bigger this time. That's why the power is negative. So the value in A is greater than the value in X, and that's why the power is negative, to make the value in A small back again. So let's check it like always. Boom. Yeah, that was a moment of awkward silence. I know, I understand. So scientific notations to small numbers, which is, as we have seen before, just a vice versa of the previous thing we learned. So these are the two examples we're going to be looking at. It's going to be 1 times 10 to the power and negative 8 first. So that's how it's written, and we'll tell you why. And trust me, it might seem like small numbers to scientific notations is harder than big numbers to scientific notations, but actually after studying this, or maybe hopefully after watching this video, you understand how to do it, and you know it's actually so much simpler. So first we're going to take a look at the 1. So as we learned before, because 1 is the number here, it is going to be the last value of the whole number. And that's because we're trying to make the number big to small, and well, small to big, and this is the vice versa of it. So if you're changing this into a decimal value, that 1 is going to be the smallest number there. That A value is the smallest or the rightmost value in the number. That's only if the power is in negative, of course. I hope you all knew that. So the arrows I couldn't really place because it's keynote and it kind of messes up with the boxes and everything. But what that's showing is, as we have learned before, the power in the negative powers in this particular kind of conversions between these two topics that we've learning before, small numbers to scientific notations and vice versa, you just have to count zeros. So to convert that, you look at the power first and you say, okay, it's negative 8. So the first thing I recommend you to do is put 8 zeros down on the paper. And after putting the 8 zeros down on the paper, add the 1 to the rightmost part of the value and put a decimal point right after the first 0. And it always works. That's just because the fact that small numbers, you place the decimal points in such a, it's easier to place the decimal points, and it's always going to be the leftmost digit that's going to give you the 1's value, which does not intervene with the next part of the number, and you don't have to worry anything about that but the zeros, which is really helpful in my opinion, especially on an exam. So you put that, you say 1 times 10 to the power negative 8 into the calculator, and you get a lot of zeros, specifically 8 and a 1 with the decimal point right after the first 0. Second example, it's 3.21 times 10 to the power negative 5. And now you guys have learned that, and I messed up my animations. I'm sorry, this was a lot of work. It took me almost like a week to complete all this. Please forgive me for the minor mistakes I've made. It's really frustrating sometimes. So after we have all this, you can read it, but I'm going to explain it too. So what we learned, we just copy paste the value of x into a. Now we're doing it but backwards. We're taking a, we're keeping it in our mind for a moment, because I've told you first look at the power. You see negative 5, then you just have to go, okay, 5 zeros on the paper, a decimal point after the first 0, and then you take 3.21 and you put it right on the rightmost part of the value without any decimal points. And the details of why this works are written down, and you're free to read them. Pause the video if you want to, but I think you already would have. So this is the value. We put it in the calculator. We get 0.40321, and of course it is right. You can do it at home with your calculator and you'll always get it right. And I'll show you a photo of the button on the real calculator. Yeah, new topic. Pre-conversion tips. I'm going to give you some handy tips that I use to be good at precise converting of units. So this might be a little dark or maybe a noir kind of feel to it because it's about someone dying, but it really helps. So you gotta memorize this. Kelly has died while drinking chocolate milk. If you ask me, that's a very insane statement, but it helps. So in the place of while, just add a small dash. I forgot what you call it. And then put the initials of every value in order. So K, H, D, dash, D, C, N. So place the basic metric units after every initial and in the dash, which means we'll have something like this if we're looking at grams. So the K is kilograms, and the H after is hectogram, decagram, gram, decigram, centigram, and milligram. You might not have learned this in school. This I learned back in India, and it's really helping me out for precise conversions. And you can use this, and so for example, if you were to convert from 1 hectogram to 1 centigram. What you'll do is put a 1 on a hectogram and put zeros on decagram, gram, decigram, and centigram, which would give you 1,000. So 1 hectogram is 1,000 centigram. Here you go. Pro conversion tips. A big unit to smaller unit. As you can see, it's a cute little elephant baby with its mom or dad elephant. They're enjoying their lives. So this is an example. Convert 2 times 10 to the power 2 kilograms to grams. Now using our method, Kelly had died while drinking chocolate milk. Memorize this, guys. It really helps. We know that 1 kilogram is 100 gram. And because there are 3 zeros between kilogram and gram, we just add 3 to the power. This is how it looks like, basically. So we're going 2 times 10 to the power 2 kilograms is 2 times 10 to the power 2 plus 3 grams. It's supposed to be grams, which will give you 2 times 10 to the power 2 kilograms is equal to 2 times 10 to the 5 grams. You can do this on paper and multiply 200 by 1,000, and you'll get 2 with 5 zeros. Hopefully this is clear. Tell me in the comments if it's not. So we're gonna check it. I used Bing converting to do this, and yes, it's 202 with a 5 zeros. So small unit to bigger unit. As you can see, a cute little chicken. Small unit to bigger unit. Example, convert 2 times 10 to the power 2 grams to kilograms. So using our method, we know that 1 gram is 0.001 kilogram. Again, the units are messed up. I'm sorry. Because there are 3 zeros between kilogram and gram, you can actually use the same method. You just put the zeros down, and if you're going from a smaller to bigger unit, you just have to divide by that number. That's how it works. It's pretty simple, straightforward. We just add a -3 to the power. We have to add -3, not subtract -3 is the catch. So hence, it would look something like this. 2 times 10 to the power 2 grams is 2 times 10 to the power 2 minus 3 kilograms. It's because we're adding -3, and you can kind of just exclude the addition value. And I think if you're learning scientific notations, you would know how to deal with negatives and positives. So I hope you understand. Oh, which means 2 minus 3 is -1. So 2 times 10 to the power 2 grams, 200 grams, is 0.2 kilograms. And it's checking time, and boom, it works. It works really well and quick. And you can also do it in your head. And thank you for watching. This is the end. I hope you enjoyed and learned something. And I'll see you later. I just want to show you. Took me 47 slides, all animated. And please remember to drop a like, hit subscribe, and ring the notification bell. Leave in the comments if you want anything else to know. A science video is in the making, and it's going to be on the channel as soon as possible. So see you guys, and bye. Tell me pretty lies, look me in the face, tell me that you love me, even if it's